into that particular topic. Okay, let me just recapitulate what we have studied in our previous lectures. Okay, in our previous lectures, we have started our electrochemistry, in which we have studied what is electrochemistry, what is electrolytes, and what is the Faraday's laws. Okay, basically after that, we have just yesterday's class completed what is molar conductivity, ionic conductivity, resistivity, and many more things. Okay, so these were the short terms which are very important as well as crucial for your chapter number 3rd, that is electrochemistry. Okay, we have studied so many numerical formulas over them. So today we will start with some numericals based on those numerical formulas, and then we would directly jump on the topic, that is change in our molar conductivity with dilution. That means हमने सिर्फ ये study किया है that we have so many terms like molar conductivity, ionic conductivity, equivalent conductivity. But what would happen if we dilute them? Okay, so that would be our main topic. And after that, we would go with strong and weak electrolytes. Okay, so let's begin with the numericals first of all, based on the formulas that we have studied. First, start with the first question that is given to us in your NCERT textbook. We have been provided with the resistance of a conductivity cell. So resistance is provided of a cell with 0.1 mole per liter KCl solution is 100 ohm. All right. Next, we have the resistance of same cell filled with 0.02 mole per liter. Resistance is given to be 520 ohm. Okay, and the conductivity of 0.1 molar KCl solution, that is kappa, is given to be 1.29 Simon per meter. And we have to calculate the molar conductivity and the kappa for 0.02. Okay, so we have basically provided with two different solutions with different concentration. First one is we are having 0.1 mole per liter, and the second one we are having 0.02 mole per liter. We have been provided with the complete data of the first complete solution, first KCl solution, but the second solution with different concentration, we have been provided with our resistance only, and we need to calculate our lambda m as well as kappa. Okay, so what can we do? We have been provided so much data, so the question is how we need to use them. मतलब ऐसा है कि हमें डेटा दिया हुआ है और हमें यूज करना ही करना है. This is not the surety ना कि हमें डाटा दिया है और मुझे उसको यूज करना ही करना है. But the point is यूज करना कैसे है. That's our first priority. So first of all, what would we do? With the help of 0.1 mole per liter solution, we have been provided with R as well as kappa, conductivity as well as resistance. With the help of this, we can easily calculate the cell constant. Okay, क्योंकि जो cell constant है, this is somewhat which is fixed in either kind of solution because it does not dependent upon the concentration. है ना? So if I would calculate the cell constant for 0.1 mole per liter solution, that would be also valid for 0.02 mole per liter solution. Am I clear or no? The cell constant is something, the name also suggests it is something which has a fixed quantity. Okay, so if we are using a cell even with different concentration, even we keep changing the concentration, it would not affect at all. The cell constant would be same. So if would we calculate the cell constant for this, that would be valid for this also. Okay, and for the on the basis of cell constant, we can easily calculate the kappa as well as the lambda because we know the mathematical formulas. है ना? So let's begin. First of all, let's start with our first topic, that is 0.1 molar solution. We have been provided with the kappa as well as the resistance. So we know very well that our kappa, that is conductivity, is equals to G into G star. What is G? Conductance. What is G star? Cell constant. So we have been provided with kappa also and G also because G equals to 1 by R. You know that very well, na? Conductance and resistance both are inversely proportional. Okay. So first of all, we need to calculate the cell constant by kappa over G equals to G star, or I can say kappa 1 by G equals to resistance equals to Z star. Can I say that? Yes, definitely. I can say that from this equation. So we have kappa as well as R. So our G star would become equals to 1.29 into 100. That is 129. Simon would be cancelled out. I think that would be per meter. Okay, because Simon is equals to ohm inverse, and ohm inverse into ohm would be cancelled out. Okay, so G star would be equals to 129 per meter. Okay, now I have already told you that if we have calculated our G star, the cell constant, that would be also valid for 0.02 mole per liter. So for 0.02 mole per liter solution, what we need to calculate? We need to calculate our kappa, and kappa, the formula is given as G into G star, and G is equals to 1 by R from this equation. So kappa is equal to 1 by R into G star. G star is given, that is 129. The resistance is given to be 520. I hope I'm not doing anything wrong. No, it's quite true. So this is somewhat which is with the help of which we can easily calculate the conductivity, or we can say the specific conductivity. Okay, this is known to be kappa. Clear hai yahan tak? Now the kappa have been calculated by dividing the two terms 129 as well as 520. Let me just put out the exact value. That would be I think 0.248 or something. I have checked in the book. So this is how we have calculated our conductivity. Ban rahi hai baat? Now the point is, how do we need to calculate the lambda m? Lambda m represents, lambda m kya define karta hai bhai? Molar conductivity. We have studied now. Molar conductivity is something which is conductivity but of 1 molar solution. Okay, so lambda m is equals to kappa into V, first point, and V is replaced by kappa into 1000 divided by molarity. Ban rahi hai baat? So kappa we have been provided with that is 0.248 something into 1000 divided by molarity is given to be 0.02. So we can easily calculate our lambda m. We can easily calculate our lambda m. Am I clear? This is how we need to calculate our molar conductivity. And one more thing, bache, I have told you, everyone has told you, please keep in your mind that units should be in the same terms. That if we are provided with Simon, we have to put our answer in Simon. If we have been provided with centimeter, we have been provided the answer in centimeter. Okay, so please keep that in your mind. The unit of molar conductivity would be something Simon centimeter square per mole. Okay, if it is given in meter, then it would be Simon meter square per mole. So that you can easily check it out. Okay, that's not something very major problem. Okay, so this is somewhat I wanted to show you that how can we calculate our molar conductivity, but the twist here is the cell constant. The cell constant would be always constant for any kind of solution. Clear? All right. So now next move to another numerical. We have another NCERT solved example, that is in the next numerical we have been provided with all these terms, but the point over there is we have been provided with the diameter as well as the length. तो अगर diameter और length दे रखा है तो that means what is the reason? The diameter and length, with the help of this we can calculate our length as well as area. और length और area जब हम calculate कर सकते हैं, what we can calculate? Our cell constant, है ना? R equals to rho L by A, and the L by A is known to be our cell constant. Okay, so this is also dependent upon the cell constant, but the point here is we have been provided with the diameter as well as the length. Okay, so let's jump to the next numerical. achieve. Next numerical tells us the resistance of the solution is equals to 5.55 into 10 raised to power 3 ohm. So the question, the unit is in ohm, and we have been provided with the diameter is equals to 1 centimeter. The length is equals to 50 centimeter. Okay. Now we have to calculate the resistivity, the conductivity, and the molar conductivity. So the first point is, with the help of these three data, we have to calculate the resistivity, है ना? And we know very well that resistivity is defined as R equals to rho L by A. Rho is known as resistivity, and L and A we can easily calculate by length and diameter. Okay, so the answer, if I have been provided with this, my rho would be equals to R into A upon L. Hai na? So let's start. Now, first of all, in this particular question, in this particular numerical, I have been provided with length, that is very obvious, but we have been provided with diameter. And you know very well that radius is equals to exactly half of diameter. That is 0.5 centimeter. Pakka pata hai na? Same as it is, if I have to calculate the area, that is known to be pi r square. The area is known to be pi r square. The pi r square is area of circle. Okay. So pi we have been provided, suppose 3.14. R we have been provided with 0.5 the whole square. And in this way, we can calculate easily the area. So rho would be equal to 5.55 into 10 raised to power 3, that is 1000, into A, that is 3.14, into 0.5, into 0.5 divided by 50. This is known to be resistivity. Okay, you can easily calculate it by solving it. I would just simplify it with the answer 87.135 ohm centimeter. Okay, so but this was all about the resistivity, but the point is we have to calculate the resistivity as well as the conductivity. We have to calculate the resistivity as well as the conductivity. And we know very well that just as we have studied resistance का जो inverse होता है, that is equals to conductance. Same as it is, the resistivity inverse is equal to be conductivity. That is kappa is equals to 1 by rho, 1 by 87.13. You would solve it and you would get the answer. And finally, हमें क्या दे रखा है जी? We have to calculate the molar conductivity, that is lambda m. For lambda m, we need to calculate kappa into 1000 divided by molarity, and molarity have been provided in our question, that is 0.05 molar. So 0.05 molar, the kappa comes to arise 0.0114 by solving it into 1000. Simon centimeter square mole inverse. Okay, so this is known to be how we can calculate our resistivity, conductivity, molar conductivity. Okay, so these were the simple numerical formulas which you can easily calculate, but the point is you have to keep remember the formulas. Now, the formulas you have to keep remember, plus you have to take on this point that how we can calculate the area in our cell. Okay, so this was something I wanted to share with you before beginning to our topic. Now directly I'm going to jump with the topic, the variation of all these terms with dilution. Okay, so let's move with our next topic, that is variation of conductance, molar conductivity and equivalent conductivity with dilution. Let's go. The next topic is variation. Let's see, electrochemistry is somewhat which is dependent upon numerical formulas. So I would recommend you that please at least solve your in-text questions, at least in-text questions for before going to the exam or whenever you're preparing your electrochemistry. Because in electrochemistry, more chances are that you would get a numerical rather than the theoretical problem. Okay. Maximum क्या हो सकता है? We can get a difference between the cells. That would be our next topic, and we can get 1 or 2 numericals. And we have so many different parts in which we can calculate the numerical, like Faraday's laws, like conductivity, resistivity. And further, today I will teach the topic that is also based on numerical. Okay. So electrochemistry, just as physics, is quite dependent upon numericals. So please be focused on that. Okay. Now, let's first of all move with the topic variation of conductance, conductivity, molar conductivity, and equivalent conductivity, that is known to be lambda equivalent. Okay, with concentration. So we know very well that our conductance or conductivity that has been carried out with the help of number of ions. Jitne zyada we have the number of ions, the more would be our conductance. Okay, this is known to be our conductance in electrolytes or the number of electrons in metals. Okay, this is what we have studied in the last topic. So I just want to say to you, whenever we have changing the concentration, I am decreasing the concentration, that means dilution is increasing. You know very well, dilution kab possible hota hai? Whenever we decrease the concentration by dissolving some solvent into it. जब मैं कोई solvent उसके अंदर add करूंगी, the solution would be diluted first of all. Suppose I'm adding some water. Whenever I am adding some water, the concentration of that particular solution would be lower down. Quite obviously, solute की concentration जो है वो lower down हो जाएगी. Okay. So the first point is, with dilution, my conductance of electrolytes would be increased. How is it so possible? ऐसा क्यों हो सकता है? That with dilution the conductance would be increased, because we know very well that our electrolytes can conduct electricity only and only when they are getting dissociated or decomposed. This we have studied in our last class, that electrolytes can conduct electricity only when they have been dissociating or they have been decomposing. So the first point I would like to say, the conductance of electrolytes would be increased with the help of dilution. Okay, so whenever we are increasing the dilution, the conductance is getting higher. Okay, because with dilution, the number of ions would be higher. Why? Because dissociation would take place. Okay, so this is the first point. Second, we are going to move with conductivity. Okay, till now, bache, you have come to know that our conductance and conductivity, they are totally different things. They're not the same thing, I would say. Okay, so the conductivity with dilution would decrease. Conductivity with dilution would decrease. Now the question arises, how is it possible? In very simple sentence, conductivity is possible when the number of ions carrying the current or the ions in 1 centimeter cube is dependent upon the conductivity. Because conductivity is defined as something that we are having 1 centimeter length and 1 centimeter square area. In short, I would want to say that if our volume is keep changing, our conductivity would be changing. That is, centimeter cube is equals to 1 milliliter. Okay, so if the volume is changing, the conductivity is also changing. The first point. Second point, whenever the dilution is increasing, the number of ions in 1 ml would be lower down, would be less. Kyun? क्योंकि वी हैव डिसोल्व सम वाटर ना, तो पहले 1 ml के अंदर मान लो 500 आयंस जो है दे वर मूविंग, we have added some water, what would happen, that water would also take some place. So 1 ml में we have now water also and we have ions also, so the number of ions would be decreased rather than increment. Okay, dissociation हो रही है, that is first point, that is conductance, but I am talking about conductivity right here. Okay, so that would be less, so ions would be less, that means the conductivity would also be decreased. That is the second point. Okay, now same as it is, we have to calculate our lambda m as well as lambda equivalent. They both also increase with increment in dilution. Why is it so? Because both are lambda m, or I would say lambda equivalent, that is totally dependent upon V. वो वॉल्यूम पे डिपेंड करता है, एंड दैट इज अ प्रोडक्ट ऑफ कापा एज वेल एज वॉल्यूम. सो आई वुड लाइक टू से कि अगर मेरा डाइल्यूशन हो रहा है तो मेरा कापा तो डिक्रीज हो रहा है, बट वॉल्यूम इज इंक्रीमेंट. सो द डिक्रीज इन कापा इज लेस देन compensated by increment in volume. I would repeat it again. The decrement in conductivity would be compensated by increment in volume. That means ये lower down जरूर हो रहा है, but volume is also increasing. And we have the relation in multiply, so we can say with increment in volume rather than small decrement in conductivity, our lambda m and lambda equivalent would both be increased. Okay, because lambda m and lambda equivalent is defined as conductivity, but the only point is they both are dependent upon the volume. Like if I would to say lambda m, that is dependent number of moles in per liter volume. If I would say lambda equivalent, that is known to be number of equivalent ions per liter volume. Okay, so if volume is increasing with so much that it can easily compensate our conductivity, they would both increase. So in short, with the dilution, lambda m, lambda equivalent would increase, but the kappa would decrease. That is the point I wanted to show you. Am I clear with it? Have you got the point that what would happen if we would increase the dilution? Okay, so this was all about this topic. Now we are going to move with our next topic, that is strong electrolyte and weak electrolyte. Okay, so our next topic is but I hope you all are getting the point what I want to say to you. Either means numericals we have understood, or the topic that is dilution ke saath what is the change in conductivity, molar conductivity. I hope you have gotten the point what I wanted to say you. If there is still any kind of doubt, you can easily ask to me after the class is over. Okay, we have been left with 10 minutes whenever. Okay, start with our next topic, that is conductance. Okay, I would say conductivity in strong electrolytes, or especially I would say molar conductivity. That is our main topic. Okay, so we have been going to understand the same topic, that what would happen if the dilution is increasing with the case of strong electrolyte as well as weak electrolyte. Okay, first of all, we know very well that there are two different type of electrolytes known as strong and weak. Strong are something which are completely dissociated, which can produce, which can I would say conduct the electricity to a maximum content. Okay, whereas weak electrolytes are those which cannot dissociate completely. So let's start with the first topic, the molar conductivity in strong electrolytes. Okay, whenever we have understood the concept of molar conductivity in strong electrolytes, it has given us a complete equation, that is lambda mc is equals to lambda m naught minus a under root c. This is an equation which was given by Debye Huckel So what's happening over here? He has given us a relation of molar conductivity whenever the dilution is increasing. And he has given us such a equation in which we have been provided with lambda m naught as well as, and the A as well as under root C. Now the point here is what these lambda m naught, if I would rub it, then it would be okay. And A and C would define. The lambda m is known as molar conductivity of strong electrolyte, whereas lambda m naught is known to be molar conductivity at infinite dilution. At infinite dilution. What does it mean, infinite dilution? It means we have added as maximum solvent as we could do. And in this case, we would say the concentration would be equal to 0. The concentration of electrolyte would be almost 0 because we have maximum diluted it. We have infinitely diluted it. Okay. And C is known to be concentration. A is something which give us, this is a constant which is dependent upon the nature of electrolyte as well as the temperature. So for each kind of electrolyte, the A would be changed. For example, if I'm talking about NaCl, it is showing 2 different ions, so there would be some different A. If I'm showing calcium chloride, it has 3 different ions, so A would be changed. But the best point is we do not need to calculate A anywhere. We have to just remember this equation that lambda m is equal to lambda m naught minus A under root C. Okay. Now what had actually happened when he had put this equation with the help of I would say to calculate a relation between dilution and the conductance of molar conductivity of strong electrolytes. What he has observed that whenever we put a graph between the concentration and the molar conductivity, we have seen that we get a straight line. For example, I'm taking KCl. If I have different type of concentration like 0.5, 0.6, 0.7, 0.8, 0.9 or 1. So what's happening whenever the concentration is decreasing, I would say the graph is almost straight line. The graph is almost straight line. Okay. And rather than if the concentration is almost 0 of strong electrolyte, this is known lambda m naught. This I would show in dot equation that whenever the concentration of KCl is almost equals to 0, then this is known to be lambda m naught. Am I clear, bache? So this was I wanted to explain you. Rather than in this topic, we have another equation that is known to be Kolar's equation, or we can say it Kolar's law. So in this topic, we have just understood that whenever our concentration is very low of our electrolyte, the lambda m is known to be lambda m naught. Okay, the lambda m naught has somewhat different value rather than lambda m. Another point, he has said that whenever we put a relation between lambda m and C, it has almost straight line. It has almost straight line. That means they both are almost dependent upon each other. Okay, so this is known to be the relation of electrolyte, strong electrolyte with dilution, with concentration. Okay, next we are going to move with the topic Kolar's law, but we haven't left with much time. So we would study that particular topic in our tomorrow's class. In tomorrow's class, we would start with Kolar's law and the weak electrolytes and their conductance. Okay, so please be focused on tomorrow's class. That is very important. So we would start with that particular topic. Okay, so now tell me if there is any kind of doubt or query if you have in this topic or in the previous.